Well, last time we did distance time graphs, and this time we'll be doing velocity time graphs. Quick recap: distance time graphs. Distance time graphs. The flat bits are where the speed is 0. The slopes tell us the speed. We say distance over time is the speed. This is in minutes and kilometers. So when working out the speed, we'll get kilometers per minute. We'll probably need to convert that to kilometers per hour. Velocity time graphs are slightly different. The flat bits on the velocity time graphs do not indicate stationary. It's the velocity. The velocity here is 20 and it carries on being 20. So the velocity from 0 to 20 is 20. The velocity from here to here is changing. Starts at 20, increases to 30 over those 40 minutes. Here, the velocity is constant again. The velocity is 30 and it continues to be 30. On the way down here, it looks like velocity might be negative, but actually velocity starts off here being 30 and reduces to being 10. So reduces from 30 to 10, but carries on being positive. But let's do some maths on this. The questions are going to be things like, from time 0 to 20, velocity equals, well, the velocity is 20 kilometers per hour. How far do they go in the time from 0 to 20? The distance they go is the area underneath the graph. So the distance is that area there. Oh, sorry, it's not very clear. Let's make that a bit darker. The distance is that area there. Notice my units along the time are in minutes. My velocity is in kilometers per hour. That's just a little trick to fool you, to make you give the wrong answer. Well, 20 minutes, that's 1/3 of an hour, isn't it? So distance, sometimes called displacement, is 20, because that's the speed at which I'm moving, times the time I spend traveling at that speed. The time is 20 minutes. So I could say 20/60ths, because it's 20/60ths of an hour. I could straight away work out that 20 minutes is 1/3 of an hour. Distance I travel is 20 times 1/3. That equals 20/3 of a kilometre. I actually like that form, but they'll probably want you to convert it into mixed numbers. So that's 3's into 20, 6 and 2/3 kilometres. So in 20 minutes, travelling at 20 kilometres an hour, I'll travel a distance of 6 2/3 kilometres. Next, between 20 and 60. So time, 20 to 60. We begin that time period with a velocity of 20. We end it with a velocity of 30. That means during that period, I've been speeding up. That means I need to calculate an acceleration. So what is the acceleration? From this point here to this point here. The acceleration is the slope. So acceleration equals the rise. It goes up by 10 divided by the time. The time is 40 minutes. I'd rather not be working with 40 minutes. I think I'd rather say 2/3 of an hour. 40 minutes is 2/3 of an hour. 10 divided by 2/3 kilometers per hour squared. 10 divided by 2/3 is 10 times 3/2. You divide by a fraction, you change, and you flip. 10 times 3/2 is 30. over 2 is 15 kilometers per hour squared. 15 kilometers per hour per hour. So I'm accelerating, I'm speeding up. I've actually increased my speed by 10 in 2/3 of an hour. So it makes sense that in a whole hour, I will increase my speed by 15. Then for this period here, we've got what looks like coming to rest, but remember it's a velocity time graph. So in fact, we have a constant speed of 30 kilometers per hour. And then this final section, they can ask us what the velocity is or what the acceleration is during this period. Well, the velocity starts at 30, reduces to 10 over a period of 40 minutes. So let's look at the acceleration over that period. So that's from 80 minutes to 120 minutes. Acceleration equals. Now it's important to see here that actually the speed, the velocity, reduces. So it goes from 30 to 10, so it goes down by 20, minus 20, and the time it takes to go down by 20 is 40 minutes, which is 2/3 of an hour again. So the time is minus 20. Sorry, the acceleration is minus 20 over the time, 2/3 kilometers per hour squared. Equals minus 20 times, divided by a fraction, we change and we flip. 3 over 2 equals minus 60 over 2 equals negative 30. So my acceleration equals negative 30 kilometers per hour squared. That means I am decelerating. If the acceleration is negative, then I'm slowing down. I'm slowing down by 30 kilometers per hour per hour. Okay, and the final question I'd like you to ask us is, what is the total distance? So total distance. Now the total distance is the area underneath this graph. So we can work out this first bit, it's a rectangle. And I've got this section here. That's a trapezium. Then I've got this section here, which is a rectangle again. And then I've got this section here, which is a trapezium. So my total distance is, firstly, take it down into little bits, time 0 to 20. We're doing it in kilometers. So it's 1/3 times the height, which is 20, time 20 to 60. Area trapezium equals a half A plus B times H. A half A plus B times H, where A is the base, B is the top, H is the height. Now for this trapezium, this is the top or the base. This is the top or the base. This is the height. So for the area of this trapezium, I've got a half times one of these lengths, or say 20, plus this length, which is 30, times the height, that's 40, but that's 2/3 of an hour. 40 minutes, 2/3 of an hour. That equals half times 2/3 is 1/3 times 20 plus 30 is 50, which is 50 over 3. Which I've not finished this one here off, 20 over 3. Time 60 to 80. That's a rectangle. The area is the distance travelled, so it's 20 wide, well that's 1/3 of an hour, times its height, which is 30, equals 10. Time 80 to 120. 40 minutes, that's 2/3 of an hour. Oh, sorry, we're doing it as a trapezium again, aren't we? So let's save that till later. The area of a trapezium is a half. Got this length and this length. So we'll do this one first. Doesn't matter which one I do first. 30 plus this one, which is 10, times the height, which is 2/3. I crossed this out simply to set so that I was doing it in exactly the way we always do it. Do things exactly the same way over and over again, you get into the exam room and you remember how to do them. Equals a half times 2/3, that's 1/3. 30 plus 10 is 40. That's 40 over 3. So distance travelled in kilometres is the sum of those values. 20 over 3 plus 50 over 3 plus 10 plus 40 over 3 equals 10 plus, that's 70, 110 over 3. Um, 110 over 3 then, well let's change that into a mixed number, equals 10 plus 3's into 110, 3 into 11 goes 3 times, remainder 2, 3's into 20 is 6, remainder 2, 36 and 2/3. Distance equals 46 and 2/3 kilometres. So remember, velocity time graphs, flat lines do not mean stationary. Flat lines mean the velocity is constant. For this period here, the velocity is 20. Slopes tell me that the velocity is increasing or the velocity is decreasing. I work out the acceleration by finding the rise over the run. For this problem, we deliberately made it more complicated. We put minutes instead of hours. So we have to convert the minutes to hours because the velocity is in hours. The distance travelled is the area underneath the graph. So the distance travelled can be broken down into rectangles and trapezia. Remember the formula for a trapezium is half, open bracket, a plus b, close bracket, times h. And for these trapezia, that's the base or the top, that's the base or the top, and that is the height.